Hi there everyone, welcome back to Dandelion Delphi Tutorials. We're going to have a look at question 1 of the Supplementary of 2016. Usually grade 10s can do the whole of question 1 by the end of the year, but in this case parts of it includes a one-dimensional array which grade 10s won't know yet, but would be perfect exercise in your grade 11 and 12 year. To get the most from this video, go and download this paper from education.gov.za and try to do it yourself. Under past papers, you will see they do mention that they are supplementaries and they are written, this one was written in February or March. Some of the others are written at another time of the year, but they are all good practice. Just depends on the year. After or during the year of COVID, we didn't have a supplementary paper, so there won't be one for the year of 2020. This is quite an easy question. You just need to convert the value entered here in miles to kilometers, and they say that 1 mile is 1.6 kilometers. Press pause and try it yourself. I'll show you the memo soon. Important to notice is that there is a decimal value entered there, so therefore we will have to declare it as a real variable to store that input, and also that we're displaying 2 decimal points in the output. All I needed here was 2 real variables. This one is being used for the input. Important to use your string to float because the screenshot showed us that it was a real value that was entered from edtinfo.txt. And then use that value and multiply it by 1.6 to get your distance in kilometers, which is then displayed in the edit box. We can display in edit boxes. We just put the edit box.txt on the left of the assignment statement and then use your floater string f with your real variable. We're using ff fixed instead of ff currency because we're displaying the real value, and then we have the 2 to show the 2 decimal values. And in the screenshot you also saw that there was a label afterwards for kilometers. Make sure you add that. Sometimes there's an extra mark allocated there. Now we can move on to question 1.2. It is important here to read the top part because a lot of the information actually given here, which is sometimes just a description. But we are going up a mountain and we want to determine temperature. So the temperature at 1,000 meter mark is 18 degrees Celsius, and then it will decrease with 1 degree Celsius for every 100 meters of the increase in the height of the mountain pass. Take a screenshot of this because there's more to come if you don't have the question paper. So here they say the height of the mountain must be entered and it must be higher than or equal to 1,000. But this they do repeat down here. They say write code to do the following. Obtain the height from the edit box for the height of the mountain pass. Here they ask us to validate. So remember, we only do validation when we are asked to do that. If the value is less than 1,000, you have to display a suitable message, clear the rich edit of the edit box, and then set the focus to that text box or edit box. If the value is greater or equal to 1,000, then only do you calculate and display the temperature for every 100 meters traveled above 1,000 meters up the mountain to the nearest 100 meters below the top of the pass. So if they enter 1685, it should then stop here at 1600 and your degrees Celsius should be 12. But important that we are starting at 1,000 with 18 degrees Celsius as our starting point. So I'm going to move up. You press pause and try it yourself. Here we are getting the height of the mountain pass. I just called it current height. You had to string to int that. They showed you it was an integer, so from the edit box edt height. And here's my validation. I have to test if this is less than 1,000. Should you put there less or equal to, you're going to lose that mark there, so make sure you read carefully. It was less than 1,000. Then you display a message, clear the edit box, set the focus, and I used exit but you could use an else here, but you would have to include then a begin and an end, and everything below this would have to be on the inside of that begin and end. Now, when I look at my output, we can just go back there quickly. I can see that the output is at the top of the rich edit. Therefore, I would include a dot clear. So therefore, I have my dot clear there. Then my headings, meters plus #9. And then temperature, that's the heading. I don't need to set tab stops for this question. It actually works out fine. So first run your program, see if your tab stops work. If they don't work, then you can come back here and set up the tab stops. Now this was actually a perfect place to use a while loop, but I'm going to show you the repeat loop as well. That would also be correct. The reason why I say a while loop is the question here tells us that we want to calculate the temperature above 1,000 meters. But remember your validation test for below. So what if it's equal to? According to this, nothing should be displayed if it is equal to 1,000. If they entered 1,000 in here, you shouldn't be displaying anything because they say here, traveled above 1,000 meters. So in theory, the right loop to use here is a while loop. Since the condition of a while loop sits at the top, we can prevent it from running if it doesn't need to run. So if we are unsure if a loop should run at all, a while loop is usually the best one to use. Now I have to display, so this is the simple part. This is the calculated height. So I am starting at 1,000 and then it goes up, and there's my degrees that start at 18. This is just my output line. And here I am decreasing the degrees. Now, using dec, the procedure with an integer there is the same as saying I degrees is I degrees minus 1. Now, if you watch my previous videos, I've always said if a variable is on both sides of the assignment statement, we need to initialize them. Usually we initialize them to 0, but since the question said we're starting at 18 degrees, there I have initialized I degrees at 18. That's my starting point. So you'll also see your first output is showing the 18 degrees and the 1,000 for the height. My height, I've used the inc procedure here. You can use your inc procedure with 2 arguments, saying I want to increase iCalc height with 100, and that would be the same as writing the code iCalc height is assigned to iCalc height plus 100. Again, that same rule applies whether you are using inc or whether you are using this code here. Variable here is on both sides of the assignment statement, and therefore it needs to be initialized. Again, usually we initialize to 0, but here they said we're starting at 1,000. So that's what I've done here. I've initialized iCalc height to start at 1,000, and therefore it will display 1,000, and then it will have the 18 degrees. So the first time it loops, it will decrease the degrees to 17, and it will add 100 to iCalc height. When you watch the video where I explained the while loop, I always said you have to ITC, initialize test, and this would be your change, the same variable. In this case, it is iCalc height. If you don't initialize test and change the same variable, it is going to produce an infinite loop, and your program will hang. So always make sure when you have a while loop that you initialize, test, and then change. This is the height that they've entered, and what I'm doing in my while loop is I'm testing if this calculated height that starts at 1,000 is less than the current height. So should they have entered 1,000, this won't produce any output because 1,000 is not less than 1,000. And here, let's say their example was 1685. So that would be 1685. And this is my calculated height. Now you'll see I have changed my height after display. So in that way, if this goes over the 1685, so the next one there would be, it would end at 1,600 meters, then that would be displayed, but then it would change to 1,700 meters. My loop will then test here, is 1,700 less than 1685 that they've entered? No, it is not, so then it won't output that. So my values here of iCalc height will be 1,700, but it will just never display. Here is my alternative method. The inside of my loop looks the same as the one at the top. I also have my clear initializing the degrees and the calculated height. And with a repeat loop, you have to you don't have to always initialize, because sometimes the user will enter a value on the inside, or that value will get a value for the first time on the inside of your repeat loop. In this case, it was important to initialize this value because we're using it on both sides of the assignment statement here. So I'm initializing iCalc height there, and I'm repeating until this current height that the person entered is less than my calculated height. So for our example where we have 1685 entered, this will increment that iCalc height to 1,700, and 1685 would be less than 1,700. And that would be the last time that this loop executes. Remember, iCalc height would be 1,600 the last time it displays. It then changes to 1,700. And now it will test, is 1685 less than 1,700? Yes, it is. So my loop won't execute again. And in that way, I'm not displaying the 1,700 that iCalc height is at this point, because I'm displaying before I'm changing this. Here's the output again, just in case you quickly want to test your program. Here we come to a one-dimensional array, or rather parallel one-dimensional arrays. They have given us array pass names and then array pass heights. And we were asked to determine the one with the lowest height. And then added here, note that you will be penalized using a fixed value in your code to indicate the number of elements in the array. And then they just talk about using built-in functions that you have to use. And then there is the output. So Baffianskloof with 896 meters, that should be your output. And you can attempt this. Press pause. Here are the arrays. So they've declared them as constants, which is quite important to know. We have that means that they can't change. But that also means that they will always have 6 values. So they both declared values from 1 to 6. For both of these, this one containing the heights as real values, and this one the names. So both of these will always have a value of 6 because it's been declared like this as constants. Now I know that previously in my books, on my videos, I have said to you guys there are certain things you're not allowed to use. But in this case, and this was the only paper since 2008 that needed you to use this, there is a function called high. And high is not the highest value stored in the array, but rather it's a function that returns the number of elements in this array. Now, usually we're not allowed to use this because when we populate arrays, like for example, reading from a text file into an array, the array might be declared from 1 to 100, but you fill only 50. And your iCount looping through your text file will keep track of how many items have you filled. So therefore, in those instances, using high would cause you to lose lots of marks. You're not allowed to use highs, and that's why I don't recommend you use high. However, this question paper in that note, that is actually what they told you. They wanted you to use high. And in this case, it's okay to use high, because the 2 arrays were declared as constants. They will always have 6 values, values from 1 to 6, and therefore you are allowed to use them. But please note that using this function is not recommended unless it is a constant array. They talk about first principle coding, and that is not regarded as first principle coding should you use hide the function in any other instance. So take note of it, but be careful of using it. As I said, since 2008, this is the only paper that needed you to use this. So what I've done here is I declared a local variable there. You could have used this code here in there, and that will produce a 6. So iCount will be 6. It will loop from 1 to 6, but you can put that code in there. You didn't really need iCount there. I have shown you guys before my method of finding the lowest or the highest. I use the indexes of the highest and the lowest. So my program is keeping the first item as the one with the lowest value. So if we have a look there at the arrays, that would be keeping 1560 and Barclay Pass. That would initially be my lowest value. But then I'm going to look and compare the other heights to the one that is currently stored as the lowest. So I'm using iLow there in the index. So this K is looping from 2. You can loop from 1, but then you're comparing the first one with itself because iLow is now 1. And in this way, I'm testing if the current value or item in array pass heights is less than the one in the position of iLow, which initially is 1. But should this one be less, or any one in that array is less than the one previously stored in iLow, then I'm changing iLow to keep the index of this lower one, or else nothing happens. Then that makes it so easy for me to display now the name. There is iLow, that's the name of the mountain pass with the lowest value. And I'm using iLow there as well as to display then the array pass heights also stored in iLow because they're parallel arrays, displaying only one decimal place, and you would see there was meters there at the end. You can use another method where you would have to use a real variable, and you can keep the value of, let's say, well, we won't be able to do this now, I don't have a real value. But you could say keep now the one in position 1, the height of the one in position 1. So let's add the rlow. Now you'll see how much extra code I need. I also need slow because I need to keep the name of the mountain pass. I need a starting point. So I'm going to put rlow there. Now I'm going to say, okay, I have the name or the height of the lowest one now stored in rlow, but I would also need to store the name. So that's array pass names. I would also need to store the name. Now I can still loop from 2 to there. I will compare this now with the value stored in rlow. If it is, then I need to add it again. I need to add an end, and this code here needs to go in there where this 1 is now changed to K, the one that is currently the lowest one. A little bit more code, not so bad when you have just 2 arrays that are parallel, but you can imagine if you have 4 or 5, you would have to keep, and you have to display all those values. You have to have a new variable for each of them and do all of this code and that code for both. So in this solution here, without this now, this solution, I can display here the value of rlow or slow here for the name and then rlow there. But I don't recommend you do that. Let's undo and show you guys the final answer. And this is what my answer would look like. Keeping the index of the lowest one. But for both, you will get full marks. Just also remember the dot clear, because you could see that the output was at the top of the rich edit. So therefore I added my dot clear. For this next question, they give you this table. And if you see a table like this, our ideal place to use either nested if or a case statement. But I'll always go with a case statement. It's a bit cleaner and easier to find your errors than a nested if statement. And here it's about the type of accommodation. Now what you need to do is just run your program and double check that the order in which they give you the type of accommodation matches the order that they give it to you in here. And then you can use your case statement with the item index there. In this case, you can see hotel is first, bed and breakfast, self-catering, and campsites. But sometimes they shuffle these around. Again, if you don't have the paper, you're going to have to screenshot this because you need it further on. They say the price there of Wi-Fi is $150 per night. That was in 2016. Hopefully these days we get it for free. And the user had a checkbox on which they could select whether they wanted the 150 or the Wi-Fi or not. Here they say write the code to get the type of accommodation from the combo box, the number of people who require accommodation because the prices were per person, and then you had to use your checkbox to add that 150 if needed. Determine the cost per night according to these values. A good idea is maybe to just do this part first and then you can continue to watch because there's more to come. There is also a radio group with payment options, cash or card. And if they select cash, you're just going to display the price per night and round it off to 2 decimal places, or rather display it with showing only 2 decimal places in the text box. If they selected a card, you have to do the following. They say use a dialog box to insert the card number. Remember, a dialog box for input means you're using an input box. Then you need to do the following validation. You need to ensure that the card number consists of 9 digits. So that means the length of this card number must be exactly 9. And then you have to ensure that the card number consists of only digits, so only numbers are allowed. If the card number is valid, you have to charge 3% of the cost because they're using their card and it's not cash, and display the payment per night in the text box. If the card is not valid, you need to use a dialog box to display. So a dialog box to display means you need to use a show message that the card number is invalid. Then you have to set the radio button to the cash option. You can see there is the cash option, and display the cash price as the payment per night. We calculated the cash price. You have the cash price here before the extra percentage was added for the card. So maybe screenshot this as well and then add this and try it yourself. I'll show you some output now and also the memo. There is more than one example of output. Make sure you test them all. This one is for self-catering, 4 people, cash payment, Wi-Fi is checked, and that should be your amount. The next one here is hotel, 5 people, Wi-Fi as well, but the card option, and this was the card number entered. This question did not show us an example of output for an invalid card number. So what I suggest you do is to test your validation. Change one of these numbers to a letter from the alphabet and see, maybe use this then as your input. Use self-catering 4 and the Wi-Fi as your option, but click on card and enter an invalid card number where 1 digit is a letter from the alphabet, and then you should get this output. Then try it again by changing the length. Remember, it can't be longer or shorter. And do the same input and see if you get this output, because that was what they asked us to do. The number of people would be an integer, and I have iPeople here getting the input string to int from my edit box. And as I said, when I see a table, I am going to use a case statement, or else if this value here was real, the value that I was testing, that was real, I would use a nested if. But this item index, they selected from the combo box for their type of accommodation is ideal to use in a case statement. And now I'm just going to follow. If we go back to that table there at the top, you're going to see here, that's really what I coded there. So remember, an item index starts at 0. So hotel is my first option. That is 0. 1,200, 1, 2, and 3. That means I have 4 options now. Our cost has a value. I then multiply that with my number of people as input from the user. And I'm still going to use our cost as the variable. Then if they selected the checkbox, remember we can say equals to true, but it's not needed. Our if statements will tell us, well, will test by default if a Boolean variable or a Boolean property of an object is true. So either add the equals to true or not, it doesn't really matter. And then I add to the existing cost. So this cost here is calculating for those people, number of people, it's calculating how much they have to pay. Now I'm adding 150 Rand to that for their Wi-Fi access. Now, the next one, I'm using a case statement again because it's about the payment option from the radio group that they selected. The first option was our cash payment. So that would be option 0. All they asked us there was to display in the edit box, we had to display the cost and comma 10, comma 2. Now keep our cost the same down here. If they selected the card option, this option here needs a begin and an end. You can see the green begin and there is its end. Quite a few things to do in here. First, we needed to get input from the user for the card number using an input box. I'm just going to move over. I suggest that you always look at your output. So if we go back to the paper, if you're using an input box, you can go back to the paper. There's a number that the user will enter. I just enter it in here because now when I run my program and I click on this option, I can just click on OK. I don't have to sit and type that number. You're going to type it at least once. So type it in here. Maybe you have to run it a second or a third time, and then you have to continue to type it. If you did not put that value there, that is the default value of an input box. Now I need to test if it's valid, a valid card number. I have set B valid to true, assuming it's correct and valid. Now I have my if statements to test if the card number is not, the length of the card number is not 9. Should you say greater than 9? It's wrong. Should you say less than 9? It's wrong. It has to be not equal to. So if the length was not equal to 9, I then set B valid to false. Now I need to check that they're all digits. So in my for loop here, I'm going to loop from 1 to the length of that card number. And in my if statement, I'm testing if a certain character, one of the characters of the card, if that is not in the value 0 to 9. Remember, this is a string. So when I use my in operator here with a square brackets K to look at each character, and I'm going to go from 0 to 9, I have to include the quotes there because it's still a char. If this was an integer number, I can exclude it. But you can't try to string to int that. If you do that, and let's say it was an A, your program will crash there because you can't convert an A to an integer. So in this case, they can't use a string to int because we're testing if it is a number from 0 to 9. Remember, 0 is a number. Sometimes you guys start at 1. And I'm using the not. So if this character is anything else than a number from 0 to 9, I'm then going to set B valid to false. So it will be true. Let's say the length was 9, so it will stay true. But the moment one character is not the number 0 to 9, I'm setting B valid to false. And here in my if statement, I can test again. B valid is Boolean, but I can say equals to true. Don't have to, but you can do that. And I'm adding the 3% for the charge using the card option. I'm adding my 3% there. So I'm taking that cost for the cash option and I'm adding to that 3% of that cost. Else, I have to display a message using a dialog box, meaning user show message. It's the invalid card number. And then they wanted me to set the radio groups option to the cache option, which was my first one. So I'm changing the item index there to 0, which means the selected option will now be the cache option. So that this part here is if the card number was invalid. And then since our cost here is changed to the card, the extra 3% if you were paying by card, and if it was an invalid number, we wanted to use the cache option. Our cost will be the cache option if it didn't run this code, or it would be the card value if the person entered a valid number and the 3% was added. So in that way, by using the same variable everywhere, I'm able to just have one edit box and display that in there. You didn't have to do that there. If you decided to change your variable there, you would just have to move your output inside of this if statement with another begin and an end, and then also make sure that you then output on the inside of this begin and end to display the cache option. But using the same variable is actually quite convenient. But there's my editbox.txt, and we're displaying it in a currency, in rands, and then the 2 decimal values here. Now this green one here, this end, is the end of my case statement for number 1. So there you can see there's the begin, and there's the end, and there the orange end is for my case, and the red one is for my procedure. This brings us to the last question of this paper. There's toll fees, and they are now, the company is going to give away prizes. The prizes are listed in your list box. So they've used in this paper combo box, list box, and a radio group. The user is going to enter the transaction number, and then you need to use the following criteria to determine their prize. So just get input from the user there. The transaction number is, if it's a prime number, the person receives a prize randomly selected from your list box. If the transaction number is not prime, they will not receive a prize. But here they give us the algorithm, or actually just part of the algorithm of what you need to do. Obtain the transaction number, determine if the number is prime or not. Remember, prime number can only have 2 factors, namely 1 and itself. If the transaction number is a prime number, do the following. This is when they get a prize. Generate a random number from 1 to 4, including both, and then you want to select the prizes from the list box. If we have a look here, showing you the answer there. There's the list box, and no prize is, remember, item index 0. But we're picking a random number 1, 2, 3, or 4. So that is the prize that they are talking about in here. Choose a random generated index in the list box in order to highlight the prize. If the transaction number is not prime, you want to select the no prize option in the list box. So if you have a look there, no prize is item index number 0. Similar code to actually what we've done before. Press pause and try it yourself. Here's an example of a number that is not prime. Enter that, and no prize should be selected. Then if we look at the next one, this is a prime number, so enter that, and then this is where 2 was the randomly generated number. You will see in papers where random numbers are generated, they say due to the nature of the random method, the output generated by your program may differ from the example. That just means actually this part here, that it won't necessarily pick the second one. It might pick one of the other 3. It just shouldn't pick the no prize one when you test it. Here is my input from the user. Important that you use an integer number. You could see it was an integer number because we will need to use mod. And mod can only work with integer numbers. So make sure you store that number as an integer number. You could have used my method. I'm using a Boolean variable that I set to true, assuming it is prime. And the moment I find a factor, I then set it to false. But you could have used a counter to count your number of factors that the number has. Then, depend on what you would use. But in my solution, where I'm using a Boolean variable, I would have to start at 2. Because remember, 1 will divide into everything. So therefore, I'm excluding 1 from it. And then I'm looping to inum minus 1. So if they enter 100, let's make it simple. I don't want to loop to 100 because then here I'm testing is 100 mod 100, 0, which is true. And that means it won't be prime. Okay, bad example because 100 is not a prime number. But take a simple number like 7, which is prime. I can't loop up to 7 because 7 can divide in 7. So that's why I have the minus 1 there. In this section here, you could have also used inum div 2. So that really means that if I have a number, let's say 100, I only need to loop up to 50. Any number above 50, halfway to that number, will push me over the number. So any number, you can think about it. If you take a number and divide it by 2, that would be your biggest factor of a number. You can't get a number higher than that. Test it if you don't believe me. But any one of these options would be fine as long as you started with 2, not to divide by 1, and also not to divide by the number itself. And remember, this is asked often. Finding prime numbers has been asked often, but finding factors has been asked even more. So I want to take the number mod k. Mod gives me the remainder. If I take the number divided by k, which is changing from 2 to 3 to 1 less of the number, and that answer there is 0. So there's no remainder. That means that the original number can be divided by that number, which means that k, whatever k is at that point, is a factor of that number, which immediately changes the prime to false. I'm changing prime here to false because if it has a factor besides 1 in itself, then it means it's not a prime number, and I'm setting b prime there to false. Now I have my if statement. B prime, again, we could say equals to true, or we don't need to do that, because it will test b prime is a Boolean variable that it is true. So if it is true, it is a prime number, I'm going to pick a random number from 1 to 4. Remember, using random range, that number there is excluded. So this will pick a random number from 1 to 4. And then I'm setting my list box, the item index of the list box, to that randomly selected number to highlight my prize from the list box. If this was not prime, they don't get a prize, and I had to set the item index of the list box to the value of 0. Guys, this was quite a long paper because this was in the years when we only had 3 questions. Great example to practice because there's lots of things that is included in this paper, like your arrays and prime and factors and string handling. So really a very good paper to practice. Thank you guys for watching Dandelion Delphi tutorials. Please remember to like and leave comments and subscribe. And for more questions or practice and explanations on arrays, that would be in my book 2, but the rest is really in book 1. These books can also be bought on the Etsy platform, ITSI. You'll find them if you Google it as an ebook. Hope to see you soon.